Hello guys, hope you all doing extremely well. With this video, let's continue our Blend 75 series, and currently we were on topic tree. We have already solved first two problems from tree topic, and next problem here is invert flip binary tree. Let's get started with the problem statement. And here it is saying that we'll be given root of a binary tree. We have to invert the tree and return its root. Now let me explain you what do they mean by invert. Suppose the binary tree which is given to us is something like this. It is containing root node as 5. 5 is having two child nodes as 7, 4, and they also have two child nodes such as say 3, 1, 15 and 11. Suppose this is the binary tree given to us as input and we have to invert or flip it. So here inversion means that for each node in this binary tree, what we have to do, we have to take its left subtree and right subtree and swap them. Means in the place of this 7, 4 will come here and 7 will go in the place of 4. They will be swapped according to their position. So all the nodes will remain as they are, but their position will change now. The values will remain same. All the nodes will be present here, but initially the 5's left node is 7, but after inversion it will become something like this. 5, its left subtree, the root will be 4 and its right child will be 7. See, 4 has gone there and 7 has come there. Alright, now again for 4, which is the left node, it is 15. So the left one will become right one. So 15 will come at the position of right node and 11 will come at the position of left node, which was initially the right child. Similarly for the 7, which is its left child, it is 3. So after inversion 3 will become right child, and the right child, which is currently 1, it will become 7's left child, like this. So this will be our output that we are going to return. Alright, now the question arises how we will arrive here when we start from here. So what is the method we are going to use here is that we will take each node and will not take each node, we will do with the root node only, and rest of the work we will pass to recursion. Okay, so what we are going to do, we'll take 5 and we'll see, yes, 7 is its right child, we'll make it as its left, and we'll make 4 as the left child, as previously it was right. Alright, this we'll do by ourselves, and the rest of the work will be handled by recursion. We'll pass this node, we'll call this function which flips or inverts the binary tree 2 times with the left node and right node, and recursion will do rest of the work. And here we'll believe recursion that it will definitely give us the correct answer, and it will flip the left and right subtree for us by seeing that the one step that we have done. So basically always recursion have 3 steps. First one is base case, Here base case will be when we don't have any node, means we are getting null as the binary tree, then we will simply return. We don't have to invert or flip anything if we don't have anything. Okay, now the second step that we always do in recursion is the small computation. It is the part that we do by ourselves. So seeing this part, recursion does the rest of the work. So here the small computation is this part when we are by ourselves swapping the left and right child of the root node. The remaining third part of recursion is recursive calls. Okay, so in this case we are going to make two recursive calls, first for the left subtree and the second for the right subtree. Alright, I hope you understood the logic. Now let's see the code, and the concept of this invert and flip binary tree will become more clear to you. Okay, let's move on to the editor. So as we have discussed, I am going to write the code in the same way. First we'll start with the base case. So what will be our base case here? As we have already discussed, it will be when we are getting null, means no root. So not of null will be true and will come inside this if, and we'll simply return here root or null, anything we can return. We don't have anything, so we'll return null. Okay, so if we come after this if, means that we have a valid root. Okay, now we'll swap the left child and right child of this root if they are available. Okay, so I hope that you know how we do swapping normally with the use of third variable. Here also we'll need the third variable. We are simply swapping two things, root left and right. So here we are going to need the third variable. If it would have been Python, then Python or JavaScript, then we can do it without the third variable, but here we will need third variable like this. And here we'll make copy of anything that we can make copy of roots left or roots right, but here I have made copy of roots left. So I have kept copy with me safely. Now I can put other thing in this root left, and what it is going to be, it will be root right as we are swiping. So I have taken root right and put it in root left, and we have not lost it, we have already kept it in temp. So now we'll update root right with this temp, and it was initially what, roots left. So here swapping has done. Alright, so it is the small computation step like this. And now the last thing that is remaining, recursive calls. Okay, now here we are going to make two recursive calls, and one for left subtree and one for right subtree. So these recursive calls will definitely give us some root, because this function is itself returning tree node star. So we need to store that answer which will be returned to us by recursion. So let me create two variables for storing the two answers from two recursive calls. Tree node star left answer, it will be invert tree, and root left. Okay, so what I'm doing here, I'm calling recursion and saying to recursion, hey recursion, take this left subtree and invert it for me. And after inverting and flipping, it will return the root of the left subtree and it will get stored in left answer. After that, I will simply do the same thing for the right subtree. I will create a variable right answer and again call this same function recursively, invert tree, and I will pass root right. Now I have two subtrees with me, left answer, right answer. These are the two childs of the root node. Now, as I have already swapped them and rest of the part is done by recursion, I have swapped them with me and the rest of the subtree has been inverted by recursion. So the whole tree has been inverted now. Now I can simply return the root of the initial node which we got in the beginning, like this. And this is it. This is the whole code. Now let's try to run it and see if it is working. Yes, of course it is working. Now let's try to submit it and I hope that it should submit. It should be accepted, and yes, it is accepted successfully. I hope I made it clear and helped you to understand this logic of invert binary tree. This is it for this video, and if you want more such videos then you can consider subscribing my channel. Thank you. I will see you in the next video.